Hello, this is week 3, and our topic this week is probability. The discussion question is asking you to think about probability as you respond to some question about fevers and their causes. Some important terms, first of all, and by the way, just consider this an introduction. We're going to talk about a lot more aspects of probability during the week. A probability experiment is just an action that's taking place. It could be a trial that you've set up and you're getting some results. They might be counts, they could be measurements, fevers, for instance, they might be temperatures, or responses, yes, no, whatever. An outcome is the result of a single trial in whatever experiment you're performing. The sample space is a set of all possible outcomes of a probability experiment, and an event is one or more of those outcomes, and obviously it's going to be a subset of the sample space. Or consider this experiment. Suppose we roll a die, and let's say the outcome is 3. Well, we need to recognize that the sample space is the numbers 1 through 6. Any of those could have come up. So if a 3 comes up, we would say that the probability of rolling a 3 is 1 out of 6. If, on the other hand, we want our event to be the die, the number that shows up on the die is even, then we have to recognize that there are 3 possibilities there. It could be a 2, a 4, or a 6. And since there are 3 and there are 6 in the sample space, the probability of rolling an even number would be 3 out of 6, or 1/2. Let's consider doing 2 things in sequence, tossing a coin and rolling a die. And this is typically how experiments are set up. There are 2 possible outcomes here for for tossing a coin. You could get a head or a tail, and I've pictured those in this tree diagram. Now, for each of those, there are 6 possible events that could pair with those. So we can see then that in total, the sample space is going to have 12 possible outcomes. And this leads us to what is called the fundamental counting principle. If one event can occur in 2 ways, and a second event can occur in 6 ways, then the number of ways they can occur in sequence is 2 times 6, or 12. And you could extend that to any number of events occurring in sequence. Classical probability is what we're dealing with here. And classical probability simply says that each outcome in the sample space is equally likely to occur. Nothing is weighted. So the probability of a single event then is going to be the number of outcomes favorable to that event divided by the total number of outcomes in the sample space. So let's assume we have a 6-sided die, and we want to find the probability of 3 different events here: rolling a 3, rolling a 7, or rolling a number that's less than 5. I want you to think about that for those 3 events for a little bit of time here, recognizing that your sample space is the numbers 1 through 6, and then for each of these you have to figure out the number of outcomes that are favorable to the event in question. So for number 1, for instance, rolling a 3, there's only 1 favorable outcome, so that probability should be 1 over 6. Event B, rolling a 7, turns out there is no 7 in our sample space, and consequently the number of favorable events to rolling a 7 is 0, and therefore the probability of that event would be 0. Event C, there happen to be 4 numbers in that list that are less than 5, so the probability of rolling any one of those would be 4 out of 6. Okay, let's review that again and recognize that we typically express probabilities as decimals. So event A, the probability of rolling a 3, we said would be 1 over 6, or 0.167. Event B, probability of rolling a 7, since there is no 7, would be 0. Event C, probability of rolling a number less than 5, for favorable events, consequently 4 out of 6, or 0.667. Now, the range of probabilities notice, is always going to be between 0 and 1. If the probability of an event in question is 0, that means it's impossible. Rolling a 7 is impossible. If the probability is 1, that means that the probability that event's going to occur. It's certain. If the probability turns out to be in the middle, 0.5, then we would say that there's an even chance. Half the time it'll be favorable and half the time it won't. And if you're on the left side of this, the event's probably unlikely to occur. On the right side, between zero point 0.5 and 1, it's more likely to occur. The last term we need to think about is the complement of an event. The set of all outcomes in a sample space that are not favorable to that event would be the complement of the event. And if you look at the little Venn diagram over here and think about the die again, inside the green portion, we would have the numbers 1 through 6. And once we specify an event, we can start filling in some numbers. For instance, I could fill in for this event, let's see, I'm going to say the probability of rolling a 3, I'll put the 3 here. Okay, then E prime is going to be 1, 2, 4, 5, and maybe I can get a 6 up here. Up, now let's see, and a 6. I'll put it in here. And a 6. Okay, so the probability of E is 1 out of 6. The probability of E prime is 5 out of 6. And notice that these little formulas over here, the probability of E prime plus the probability of E is going to be 1. 1/6 plus 5/6 is 6 over 6. Also, since they're complements, the probability of the event E is equal to 1 minus the probability of the complement. And likewise, the probability of the complement is equal to 1 minus the probability of the event. Okay, hopefully that serves as a nice introduction, and we will do a lot more with probabilities this week. If you have any questions, just please click on reply.